Hello all you lovely people from YouTube, and if not YouTube, from Flipgrid. In that case, you're my engineering teacher. I'm here to teach you stuff. But what kind of stuff, you may ask? I'll be teaching mechanical advantage, what it is and how to use and interpret it. Now, what is mechanical advantage? Surely you've heard of it, but let's be honest, you probably don't know what it is. Mechanical advantage, or MA for short, is an equation that compares resistance and effort. Effort is the force being applied, and resistance is the force that opposes the effort. Here's an example of effort and resistance. John is lifting a heavy box of his trophies from baseball. The effort is John lifting, and the resistance is the heavy box. That's the basic gist of mechanical advantage, but how do you actually find it? To do that, we need to first talk about the types of mechanical advantage. We're going to talk about the easy one first, actual mechanical advantage, or AMA for short. AMA is the mechanical advantage of real values you collected from testing. In simple terms, the effort is the actual force put into a task, and the resistance is the actual force resisting the effort. To find AMA, you need to do the equation F of R over F of E. If you're scared by it, don't be. Fractions are just a fancy way to write a division problem. Notice the variables in the equation. For those of you who don't know what it is, a variable is a letter or symbol used to represent a numerical value. Got it? Good. The value F of R represents the force of resistance, while the variable F of E represents the force of effort. Now let's say that John wants to know the actual mechanical advantage of lifting his box of trophies. John is applying 15 pounds of force to lift the box, which is his effort. The box also weighs 15 pounds. You divide the effort force by the resistance force, and as you can see, that the AMA is equal to 1, or in a ratio 1 to 1. The effort is the same as the resistance. When calculating AMA, always remember that you're using real forces and measurements during a test or task. Actual mechanical advantage was easy enough, but now let's talk about its counterpart, ideal mechanical advantage, or IMA for short. IMA is similar to AMA in the sense that you have effort and resistance. However, instead of using force values, you use distance. It's called ideal mechanical advantage because you have no actual data to work with, only dimensions and blueprints. IMA is calculated usually during the design phase of a project. Now then, how do you actually calculate IMA? It's similar to AMA in the sense that it's a division problem. The difference here is that the effort is divided by the resistance instead of the other way around. As for the variables, we use d of E to represent the distance of the effort, and d of R to represent the distance of resistance. Going back to John, let's say that we didn't know how heavy the box was, or how much effort he was putting into lifting the box. John is going to lift the box 60 inches, and the box is 24 inches tall. You divide the effort by the resistance distance, and your ideal mechanical advantage is 2.5 to 1, or just 2.5. Mechanical advantage is easy enough on its own, but how do you interpret your answer? As we already know, mechanical advantage is a ratio, a comparison between the resistance and effort forces. On top, you will have your mechanical advantage value, and on the bottom, you have 1, your reference unit. If mechanical advantage is equal to 1, the resistance and effort are the same, nothing is gained or lost. If mechanical advantage is less than 1, then you are at a mechanical disadvantage, whereas if it is greater than 1, then there is a mechanical advantage. So what did you learn today? You learned that mechanical advantage is a comparison between resistance and effort forces, a ratio, how to calculate both ideal and actual mechanical advantage, and how to apply and interpret mechanical advantage. And as always, if you have any questions or anything else to say, feel free to leave a comment, or maybe subscribe on my YouTube channel. You know, I post some good stuff. It's not consistent, but it's good stuff. Do it. Or else.